Okay, then that leads us to talking more about angles with relation to boats and navigation. So we're going to be looking at what's called bearings. And there's actually two different types of notating bearings. One is a more traditional way, I guess, and this is what is some people call directions. The bearing from point O to point P is the acute angle measured in degrees between ray OP and a north-south line. That sounds more confusing than what it is. Here are some examples of bearings. North, 40 degrees west, and you can see all of that. So there are three parts to naming bearings. The first part is going to be NRS for north or south, and there's going to be some angle measure given to you, and that angle measure is always going to be acute, and it is always going to be in degrees for what we're doing. This isn't always going to be an acute angle. And then the third part of your bearing is going to be either E or W for east or west. So I go through these three steps here on how to write a bearing from O to P. At P, the point that you want to end up at is above the east-west line. Remember, we're starting at point O and we're going to point P. So if point P is above the east-west line, so it's north of the east-west line, you're going to start with N. If it's south of that east-west line, you're going to start with S. So the second step would be to write the measure of the acute angle formed by ray OP and the north-south line. And then the last part of your bearing is determining that east or west. Well, if you're east of the north-south line, you write E. If you're west of the north-south line, you write W. And we're going to go through a couple of examples here. Now, before I get started on naming this stuff over here, I want to fill in the measures of all of these little angles that aren't written down. Right? So this is a right angle here. So I would have 90 minus 58. This angle is 32 degrees. This is going to be 60 degrees. This would be 20 degrees. And this would be 41 degrees. Okay. So I do that first of all, because I know that over here, I've really got 4 problems in one. So I'm just going to go ahead and do that all at once. Get that over with. Okay, find the bearing from O to A. Okay. So we are above
the east-west line.
So we're going to write in. Now you're going to think of yourself as standing at this point and facing north. Right? Think of yourself as standing here and facing north. We want to end up at point A. So I have to turn 32 degrees toward the east. So turn 32 degrees toward the east and then head off in that direction, and then I'll end up at point A eventually. Okay, now to get to point B, so I'm above or north of
the east-west line.
So I'm going to start off by looking north. Think of yourself as standing here and looking north, looking straight ahead. I want to get to point B. So I'm going to have to turn 41 degrees toward the west. Turn 41 degrees toward the west, and then head off in that direction, and I'll eventually end up at point B. Notice that, point A was north and east of my starting point. So I got north and east here. Point B was north and west of my starting point. So I've got north and west there. So usually you can eliminate one or two of your answer choices, based on your starting point or your starting direction or your ending direction. All right, then to go to point C over here, you are below the east-west line or south of the east-west line. So you're going to start off with an S. So think of yourself as standing here and looking south. And you want to turn 70 degrees toward the west. Remember that the angle that you're putting here is always going to be an angle that is made between your terminal side and your north-south line. These are not reference angles. Remember when we were talking about reference angles, we would never want to use these angles in here because it was connected to the y-axis. Well, here, this is what I want to do. I do not want to use the reference angle. Okay, so to go from O to D, start off with O. I'm below the line, so I'm looking south, and then I'm going to turn 60 degrees toward the east, and then that will give me the direction of where point D is. Questions with that? Okay. Let me give y'all a second to try to name these points or these bearings on this next graph. Okay, this is going to be north 40 degrees east. This is north 42 degrees west, south 71 degrees west, and south 59 degrees east. Oh, which one? Oh, okay. Yeah, it is 30 degrees. I'll write that again. Thank you. 30 degrees east. Any questions with that? Okay, the next page, or the back part, we've got word problems that we're going to be looking at. A boat leaves the entrance of a harbor, travels 66 miles on a bearing of north 56 degrees east. How many miles north and how many miles east from the harbor has the boat traveled? Remember that bearings are going from like point O to point P. So here I am starting at some point O, the harbor in this case. And I'm starting off by looking north, and then I'm going to turn 56 degrees toward the east. So I've got this point P here that I'm looking at. This angle is 56 degrees. Does everybody understand how I've got that? Oh, and I also know that the length of this side here is 66 miles. So I've gone 66 miles. I want to know how far east and how far west have I traveled. So I can draw in this right triangle here. Not how far east and how far west, how far east and how far north have I gone? This value here, I'm going to call X. This value here, I'm going to call Y, because I know that this point P is the point XY. Well, this leads me back to my circular definitions of my trig functions. But there's one thing missing here, and that's this angle. I do not use 56 degrees. I have to use this angle in here, which would be 34 degrees. So now I can look at the sine of 34 degrees to be opposite over hypotenuse, so y over 66. And then I could use the cosine of 34 degrees as adjacent over hypotenuse, so x over 66. I'm going to actually write this. Sine theta is y over r, where r is my radius, or in this case, my hypotenuse. So I have the sine of 34 degrees equals y over 66. So y is going to be 66 times the sine of 34 degrees. And then I can do a similar thing over here with cosine. Cosine of theta is x over r. So the cosine of 34 degrees would be x over 66. So x is going to be 66 times the cosine of 34 degrees. So now you know the exact values for x and y. If you wanted to estimate this, and I think your directions will ask you to round to the nearest tenth, then you just put this into the calculator. Here you're going to get 36.9 miles, right? And this is how far north you've gone from the harbor. And you put this into the calculator and you get approximately 54.7 miles. And that is how far east you are from the harbor. Question with that? Okay, forest ranger sights a fire directly to the south. A second ranger, 7 miles east of the first ranger, also sights a fire. And the bearing from the second ranger to the fire is given to you. So how far is the first ranger from the fire? It's very tempting to want to start drawing your picture with relation to that first ranger, but you're given information about the bearing with relation to the second ranger. So the second ranger is really the one I'm interested in here when I start drawing my picture. So this second ranger spots a fire that is south 30 degrees west. So here's my fire. This is my fire here. This is 30 degrees, right? He starts off looking south and then he's going 30 degrees toward the west. This is my second ranger. So I know this angle here is 60 degrees. Now, going back to that first ranger, it says a forest ranger sights a fire directly to the south. Well, this is where my first ranger is over here. And I know that this length from the first ranger to the second ranger is 7 miles. So I want to know how far the first ranger is from the fire. So I think this problem is interesting because it's all about drawing your picture. Once you draw your picture, then you know that you're looking at this side length and you know this angle measure and you know that side length. Well, what relates this angle of 60 degrees and the adjacent and opposite sides? Well, that's the tangent. The tangent of theta is opposite over adjacent. So I know that the tangent of 60 degrees is going to be x over 7. So x is going to be 7 times the tangent of 60 degrees. Stick that into the calculator and you get approximately 12.1 miles. Are there questions with that? Okay, the next problem, you leave your house and you run 4 miles due west, followed by 2 miles due north. At that time, what is your bearing from your house? So my house is like my origin here. This is where my house is. So I go 4 miles west and then 2.5 miles north, and I'm going to end up at this point P here. 4 miles west, 2.5 miles north. If I look at this angle theta, that will relate opposite over adjacent. Tangent of theta is opposite over adjacent. So the tangent of theta is 2.5 over 4 to figure out that angle measure theta. That is the inverse tan of 2.5 over 4. So you would put that into your calculator and you get approximately 32 degrees. Okay. You're not done yet. You want to actually know what this angle is here in order to get your bearing. So I have to do 90 minus 32 degrees, and that will give me 58 degrees. So I start off by looking north, and then I'm going to go 58 degrees toward the west, and that will give me my bearing to get from the house to point P.